Lucky we have George.
Yes. So I was just saying that I think the best way to think of languages and grammars is just to not connect them in any way to what we normally think of as a language or a grammar. For our purposes in this chapter, a language is simply a set of strings. Just to give you one example, I could say that the language of syntactically correct C++ programs, that's a language, right? Because every string is either a syntactically correct C++ program or it's not a syntactically correct C++ program, right? Did that part make sense? Like if I give you a string of characters and you look at it, you can say, oh, this string of characters that you just gave me, that's a syntactically correct C++ program. So this language that we're defining here on this line in the text is just any string, any syntactically correct C++ program would be part of this language. And then a grammar then is simply a technique for representing a language, or for a technique for saying what is going to be in the language, what strings are going to be in the language. Okay. I think the best way to look at that is to just look at an example. For the most part, probably if I just show you an example, you can kind of intuitively see what's going on. So here we have a grammar that is supposed to explain what strings are in the language that consists of C++ identifiers, right? So you can imagine that there is a set of strings that are valid C++ identifiers. And so the way we're going to do that is every time you see this vertical bar, that means or. And then if you see something in angle brackets like this, that means that you have to go look that up to see what that is, and then insert one of those right there. Okay. So what this is saying is, what this grammar here is saying is that a particular string is in the set if it meets the definition of letter, or it meets the definition of identifier, and then there's a letter afterwards, something that meets the definition of a letter after that. So these things are just right next to each other. So that means first there's an identifier and then there's a letter. Third option is it could be an identifier and then a digit. Okay. So you can see the connection to recursion here. Grammars are typically defined recursively, right? In my definition of an identifier, I've got, you could think of this here as being sort of the base case, right? It's just a letter. Or I've got my recursive case where I actually refer to the word that I am defining. And then letter and digit are simpler, right? A letter is just one of those 53 possible characters. And then a digit is just one of those 10 possible characters. Okay. So does it make sense that an identifier in C++ is either a letter, or it's a valid identifier followed by a letter, or it's a valid identifier followed by a digit? And all right, I'm going to go with that unless someone can ask a question or wants me to try to say more about it. And we'll see a couple more examples. I mean, as a matter of fact, I think I'm pretty much done talking about new stuff. Basically, what we're going to do now is just see some examples. So something he does that I haven't really focused on in the past when I've taught this stuff, but I was looking at it today and I was like, you know, this is this is actually kind of cool. So let's just look at it for a second. I don't want to overwhelm you, but what he's saying is that this grammar can be translated into code, right? Because it's really just a recursive definition. And so we're going to say the base case would be if the length of the string is 1, then if it's a letter, return true, otherwise return false, right? That's our base case. Otherwise, now then we've got two recursive possibilities. If the last character of S is a letter or a digit, so that's coming from here and here, if the last character of the string is a letter or a digit, then I'm going to just see if everything except for that last character or digit is a valid identifier and return that result. Okay, anyway, so you can take a look at that on the text if you want. I'm not going to actually hold you responsible for sort of, having a good grasp of how the grammars can be translated into algorithms, but it's kind of cool, I thought. Okay, so now we're just going to look at a couple examples. We've seen palindromes before, right? We had a palindrome function in assignment 2. So here's the definition of a palindrome. It could be an empty string. Think of that as sort of like a base case, right? It could be a single character, so that's another base case. Or it can be something that meets the definition of a palindrome with the same character at both ends. I guess the same letter at both ends. Okay, and then we just have to define CH, in this case, actually means letters. And how does that make sense? It kind of makes sense how that's going to produce, this grammar is going to produce palindromes. So, I could, if I had the string A, B, B, A, then I would say, okay, well, I'm going to apply this rule first, right? And that tells me that the string A, B, B, A is a palindrome if I take off the A's and what's left in the middle, which would be just BB, is a palindrome. So now I have to call palindrome recursively or apply it recursively to see if the string BB is a palindrome. And so I see that the string BB could be a palindrome if I strip off the B's and what's left is a palindrome, right? If I strip off the B's, what's left is the empty string. And it turns out that the empty string is in fact a palindrome. So I match, okay? Any questions about the palindrome grammar, the palindrome language? And it kind of makes sense that when I say the language consisting of palindromes, you can just imagine there's a set, and what's in the set is all the possible strings that meet the criteria of being a palindrome. Okay, here's just one more example. Strings of the form, actually, let me pause for a second. First of all, I just realized that there was some chatting going on. Okay. I wanted to see, I'm going to change the size of this because it's kind of small. I want you to tell me if it changes on your screen or not. I kind of think it doesn't, but I just made mine a lot bigger. Did that make yours bigger or not?
No,
Not mine.
Changed.
Okay.
Yeah, no change.
I can see it just fine though on my screen.
Or you know what, I can actually, I think that makes it bigger, right?
Oh, there
Yeah,
you go,
that
yeah.
Okay, that's probably a little better. All right, we'll go with that. Okay, so just one more example on the languages and grammars. So strings of the form A to the N, B to the N. In other words, a string of A's followed by a string of the same number of B's, right? So you can imagine that if we were to list these out, we would be listing every possible string that has the same number of A's followed by the same number of B's, or a number of A's followed by the same number of B's, okay? And so here's the grammar, okay? And we're just saying that a legal word, it's either going to be an empty string or it's going to be something that meets the criteria of a legal word with an A tacked on the front and a B tacked on the end. Okay, so does it make sense that this grammar is going to generate all possible strings that start with a bunch of A's and then it's followed by the same number of B's? Okay. That's pretty much all there is to it. And I hope you kind of see, even if the code here doesn't make total sense, and I kind of think it should if you just take a look at it later maybe, but it should kind of feel similar to recursion, right? Because you've always got to have a base case, you've always got to have a recursive case, assuming that it's defined. I don't want to imply that all grammars are defined recursively, but it's pretty standard. Okay, so I think there's a question we can work on here just to see if we've got it. Consider the language of these character strings, $CC, $D, CCC, $DD, and so on. So let's write a recursive grammar for this language. I think I'm going to pop into Excel here. Give me a second to get this going. Yeah, give everyone else a chance to think about it first, Kaylin. Sorry, I'm just trying to figure out how to deal with my screen space here. Okay, so just to be clear, let me make oh boy. Sorry, trying to get my Excel set up here. And then I'm going to share my whole screen. Okay, so let's think about our base case. What's our base case going to be?
$sign.
$sign, right? There is no empty string in this language. So the base case is going to be $sign. So a string in this language is going to be either a $sign or it's going to be, we're going to put two C's in front of it and one D after it, right? As long as we put two C's in front of it and one D after it, that's going to maintain the pattern of having twice as many C's in front as we have D's behind. So it would just be C, C, S, D. How's that look? Any questions about that? Okay. So I think I have you do a couple of problems related to this, but basically all you really are going to need to do in the exercises or on a quiz or whatever would be, I give you the grammar and you tell me some strings that are in the grammar, or I describe the language. I'm sorry, I guess I should say you tell me some strings that are in the language, or I describe the language to you and you write the grammar for me. Okay, basically just going back and forth between those two things. And that's all I'm going to ask you to be able to do with grammars and languages, at least at this point. Any questions about languages and grammars? Okay. Let's talk about the next thing on our agenda. And this is something, this is super important stuff. We're going to be coming back to it a couple more times over the course of the semester. And basically what we are going to be talking about is prefix expressions, infix expressions, and postfix expressions. The usual kind of expression that we deal with as humans is an infix expression. It's called infix because the operator is in or inside or in between or whatever its operands, right? So here we have W divided by K, right? The operator is the division, and the operands are the W and the K, and the division is in between the W and the K. Prefix notation would be the operator comes before the operands. So you would write, let's see if he actually does this. He must be doing this soon. Right, so he does it right here. A plus B, this is infix expression. In prefix, we would write it this way. Postfix, we would write it this way. Operator comes after the operand. One main reason, the primary reason I believe that this is useful is that infix expressions involve a lot of ambiguity. You have to have parentheses to say what you mean. You have to have operator precedents to say what you mean. With prefix or postfix expressions, there's no ambiguity, and it makes it a lot easier for the computer to handle the expressions. Turns out that, I can't remember if it's this week. No, it's not this week, but in a couple weeks, we're going to actually be writing a function that evaluates infix expressions. And the way we're going to do it is we're going to first convert the infix expression into a, I can't remember if it would be prefix or postfix. Postfix, I think. We're going to convert it into a postfix expression and then evaluate the postfix expression because it's so much easier to write code to evaluate a postfix expression as opposed to writing code to directly evaluate an infix expression. So that's at least one way of thinking about the justification for all this stuff we're going to be doing. And basically, I'm going to just say that for this chapter, all I'm going to need you to do is be able to take an expression that is in one form and convert it to another form. So here's an infix expression, write this as a postfix expression, write it as a prefix expression, and vice versa. The only other thing that I might throw at you is I might say, tell me whether this is a valid prefix expression, tell me whether this is a valid postfix expression. But basically the same skill. I think what I want to do is just dive into an example. Okay, so let's look at question 2 here. So we want to write the prefix expression that represents the following infix expression. So A slash B times C minus D plus E times F. Okay, so here's my suggestion about how to do this. There's different approaches, you could tackle this from different directions. But when I look at this expression, what I notice is that I look for the last operator that's going to get applied, right? Anyone want to tell me what the last operator is that's going to get applied in this expression?
Minus.
Minus, right? So we can think of this whole expression as being the first operand is this stuff over here. The second operand is this stuff over here. So when I convert that into prefix, that means I'm going to have the minus first, followed by this first expression here translated into prefix notation, followed by this second operand here translated into prefix notation. That makes sense so far? So basically we divided our task into 2 now that we can think of separately. Once again, might sound a little bit like recursion, right? Now we're going to be, the next thing we have to write here is we have to write the equivalent prefix expression to this infix expression here on the left. Okay, so I'm going to ask myself that same question again. Just looking at the A divided by B times C, what's the last operator that's going to get evaluated? The star, right? Right. So that's what I'm going to put down next. The next thing I'm going to have here is a star with A divided by B being the left operand and C being the right operand. Okay, so another recursive call. The next thing I need to do, I just said that A divided by B is the left operand. How do I write A divided by B in prefix? That would be B, A, I'm sorry, B. That would be divide A, B, right? So that there, I don't know if you can see up there, but as well as you can see down here, but is the left operand to the multiplication operator. So the next thing we have to write is we have to write the right operand to the multiplication operator, which is the C. Okay, so this part of the expression right here is the complete left operand to the minus operator. Everyone with me on that? How's it going? Have I lost everybody? Good, okay. So what's left now is, and just for our purposes here, this isn't actually in the expression, but just so I can keep it straight, I'm going to put some brackets around there just to remind myself, okay, that's the left operand to the minus sign. Now I need the right operand, which is going to be that D plus E times F, right? So the last operand that's going to get evaluated there is the time. I said that wrong. The last operator that's going to get evaluated there is the times. So I'm going to start with that. The times operator's left operand is the D plus E, which I write like that. And then the times operator's right operand is going to be the F. And then just for my sanity, I'm going to put that in square brackets so I can see it. Okay? So that, I believe, is the correct answer. Let me get rid of the square. I want you to look at it with the square brackets there. Actually, let me just leave them there. Whoops. Oh, it doesn't like that I'm starting with a minus. All right, what's the trick in Excel to get it to just treat this like text? Okay, well, guess I should have used Word. There was a method to my madness, but so I'm going to take the square brackets off. Because the square brackets help us humans, but they don't help the computer at all. Okay? So there's my answer. Better if I put it in quotes. There we go. Okay. Any questions about how we did that? All right. Let's take a look at question 3. This is just going the opposite direction, right? Now we're given a prefix expression, and we are supposed to translate that into an infix expression. Really tempted to switch over to Word here. We'll see how it goes. I'll just use quotes. Minus a slash b plus c times d. Okay, so let's do some analysis here. I can look and I can see, okay, if I see an operator followed immediately by 2 variables, then I know that that is going to be one of the sub expressions, right? So in my mind, I can kind of maybe put that in square brackets. Okay? So this is just, I'm just kind of tracing through with you guys the way that I would be analyzing this, okay? So the next thing I notice is that there's this plus here, and it's got 2 operands after it, right? There's a plus followed by a C, followed by what I have determined is a complete sub-expression, so that'll be the second operand to the plus operator. Should I say that again? So what I'm saying is that I know from my analysis now that I can put square brackets around this plus and over here, and that represents a sub-expression. Okay, then keep on going. I've got this division here. I know the first operand to the division is going to be the B. The second operand to the division is going to be the big square brackets here. So I'm basically going to go one step further with the square brackets now. And I've got this divide with B as the left operand and all the rest of that stuff as the right operand. Okay. Now look what I've got. I've got a minus here. The left operand to the minus is clearly the A. The right operand to the minus is the rest of the stuff in the big square brackets. But then what's happening after that? Any thoughts about what's going on there? I have to admit, it's kind of a trick question. Turns out that this expression is not a valid prefix expression, not a valid prefix expression. Because if you look at it, now what I have left is I have an operator with 3 operands in a row, right? So it doesn't match, you could say that it doesn't match the grammar for what is a valid prefix notation expression. So it turns out that that's actually a typo in the 6th edition of the textbook. And really what it's supposed to be is it's supposed to be 2 minus signs in front.
I was gonna say that's like a hard trick question.
Yeah.
Yeah, that's what I
I
was
would.
thinking too. I was like, oh my god.
Yeah. So, but good exercise, I think, right? Just being able to see something like that. Anyway, so now what we've got should make a little more sense, right? I've got this minus sign, the second minus sign here. The left operand of that minus sign is going to be the A, and the right operand of that minus sign is going to be all the rest of the stuff in the square brackets. So I'm going to put that whole expression in square brackets. And then I have the outer minus sign with all the square brackets as the left operand and then the F as the right operand. Okay, so now I've analyzed it. I can start converting this into infix now. So this minus here is going to have a bunch of stuff on the left and then just the F on the right. So let me write that as minus F. Oops, forgot my quotes. Something, right? Something minus F. Everyone okay with that? So that takes care of the outermost expression. Now I'm going to start working my way in. The next thing I see is a minus with A on the left and a bunch of stuff on the right. So I'm going to replace these question marks with A minus something. A minus something, minus F. Okay, so now my point is that if I replace the question marks with no, it won't let me get in there. With this, I'm done, right? So I slow down, back up, keep going.
Makes sense.
Okay. So I started off with the outermost minus, and I said the outermost minus is going to be all of this stuff minus F, right? And now I'm saying, okay, all of this stuff is going to be A minus all of this stuff. Okay, so now I'm going to say the 3 question marks is going to be the division with B as the left operand, and then all of this stuff as the right operand. So I'm going to replace my question marks with B divided by something. Oops. Okay. Now, what I'm saying is that the another close paren, right? Yeah. Yeah. That if I replace these 3 question marks with this, I'm done. Right? So what that is that's going to be a plus operator with a C as the left operand, and then this remaining stuff, the star DE, as the right operand. So a plus sign with C on the left, and then star DE on the right. So C on the left, and then star DE on the right. I can do that pretty simply, right? That's just D times E. Okay, how's that looking? Some of these I can get, some of the parentheses I can get rid of, right? I can get rid of the parentheses around the D times E because that's going to be taken care of by the precedence of the operator. And I can get rid of the parentheses around the division because that'll be taken care of. Yeah. And I guess I could get rid of one more set of parentheses because this minus sign just is going to come before this one because it comes to the left of it. Anyway, I'll stick with this for now. I think you're also fine what you wrote down there, Kenny. All right, any questions about question 3? Okay, let's look at question 4. We got to figure out whether this is a prefix expression. I think the only, for me, that looks complicated enough that I feel like I'm going to just type it out just to make sure that I don't get confused. Plus, minus, divide, ABC, star, plus, DEF, star, GH. Okay, so here's the way we can approach this. Anytime I see an operator followed immediately by 2 simple operands, I know I can just block that out and say, okay, that's an operand, right? So maybe I can indicate that by, I'm just going to replace it with square brackets. Okay? Does that make sense what I'm doing? This is totally just, I'm kind of making this up just so I can keep track. Okay? Then I've got plus DE. That's going to be a complete sub-expression. So I'm going to block that out with square brackets. Then I've got star with a left operand, and then the right operand would be the F. So I could block that out and call that an operand. Then I've got divide AB. So I'm going to block that out and call that an operand. Then I've got minus operand C. So I'm going to block that out and call it an operand. And what I've got left is an operator with 3 operands. That's not going to work, right? So the answer to question 4 is no, that is not a prefix expression. Okay? Any questions about any of that? All right. All we really have left is postfix expressions, and really there's nothing new. We just do exactly the same thing again, except the operator comes after instead of before. So I guess we could just take a shot at question 5 here. Looks like I forgot to label question 4. Oh, yeah, anyway. Write the postfix expression that represents the following infix expression. So let me just write that down. A times B minus C divided by D plus E minus. Okay, so again, what's the last operator that's going to get evaluated? It's going to be the plus, right? Okay, so I'm going to say everything to the left of the plus, and then everything to the right of the plus, and then the plus. So I think I could actually just type that, right? I could say, so what I'm doing now is I am converting to postfix in stages. So that's what's going to be the first operand. And then the other operand is the E minus F. And then the plus goes at the end because we're converting to postfix. Everyone see what I did? So obviously now what I need to do is I need to convert this operand into postfix and convert this operand into postfix. Let's do the E minus F first. That's going to be pretty easy. That's going to be just EF minus, right? So let me just copy the rest down for now. Oops. And then after that, I'm going to have EF minus plus, right? And maybe just for my sanity, I will put square brackets around that so I know that that is one of my two operands. Okay. I hope this isn't too confusing. I'm kind of mixing up infix and postfix because I'm just converting one part at a time into postfix. Hope that's clear. So now what I'm going to do, I'm looking at this operand. I need to convert this thing into postfix. I noticed that the last operator that's going to get evaluated here is the slash. So I'm going to have the A times B minus C as the first operand, and the D as the second operand, and then the slash. So I think what I'll do is I'll do that on the next line. I promise I won't make the quiz too hard. Okay, so what I'm doing here is I'm going to leave the A times B minus C there because that's the first operand, and then I'm just going to put the second operand as the D, and the operator is the slash. Okay? And there's my square brackets to just help me keep things straight. So now I'm done, except I just need to convert this A times B minus C into postfix. So that's going to be minus with A times B being the first operand and C being the second operand. So I'm going to say A times B, and then C minus. And I'm going to get rid of the parentheses. Okay, so now what I have is I have converted the whole thing into postfix except this A times B. So I'm just going to go back in there and put, in the place of A times B, I'm going to put AB times. Okay. So I've got here's my A times B, and then minus C, and then divided by D. So that's my left operand. And EF minus is my right operand. And then plus is the last operator. So let me now just get rid of all of my notes to self. How's that look? AB times C minus D slash EF minus plus. All right. Anybody want to ask any questions about that? Oops, I did not mean to do that. Yeah. So this is definitely one of those things where my guess is that when you're just watching someone else do it, you have no idea whether you're going to be able to do it yourself when you try it. So you just got to wait and give it a try, and you know, let me know if you get stuck. All right, I think that's pretty much all we need to do with prefix and postfix. The next thing is we're diving into backtracking, which I would refer to as basically just, all right, let's do some more advanced recursion. And I think the best way to do that is, what I would like to do is actually go through the pseudocode from the assignment, trace it through, and watch how it's going to solve the 8 queens problem. I'm not sure if we're going to have time to finish that completely today, but I guess we should just see how it goes. All right, give me a second to get things set up here. Gonna want pseudocode on the left, and I'm gonna want Excel on the right. Pink. Ah. Okay, so yeah, the 8 queens problem is, you know, one of the most famous computer science examples of backtracking recursive algorithm. So it's one of those canonical problems that, you know, when you get to your upper division classes, everyone will just sort of know about the 8 queens problem. I think I'm just going to get rid of all of this. Oh, I forgot you guys couldn't see what I was doing. Hold on. Go to Zoom. Click on share screen. Desktop. Okay. So this is going to be a little tricky, but what we need to do is, okay, so here's my place queens function. And there's going to be a calling object of type board. This is a member function of a class called board. So I'm going to draw a picture of that board. Let's see, and we're just, instead of doing the 8 queens, we're going to just do 4 queens to make it a little more manageable. So let's see if I can draw a reasonable picture of that. I want a thick line, and I want all borders. Okay. Whoops, I got more than I wanted. I got 1, 2, 3, 4, 5, 6. No. Sorry, you guys get to watch me play with Excel borders just for another minute. All right, so this is going to be my board calling object. And then over here, I'm going to keep track of each instance of the place queens function, because we're going to have a new instance of the place queens function for each column. So I think we can see that as we go. I think I'm going to, never mind. I figured out a way to do it. Okay, so let's take a look at this function. We're going to call place queens with row equal to 0 and column equal to 0. So row 0, call 0. All right, let's start going through the code. Beginning with row 0, find the next square in column 0 that is safe. So I guess maybe I should have numbered these, but hopefully, well, I can number the columns easily enough. All right, and the rows. Okay, and I'm gonna move this over a little bit. Okay, so find the next square in column call that is safe. By safe, I mean, and I explain this up here, by safe we mean it is not under attack by a queen in a preceding column. Okay, so in this case, the next square in column 0 that is safe is row 0. So it's going to be this upper left cell right here. Okay, while such a square exists, set the location of the queen in column 0 to that square. I'm going to indicate that just by putting an X. Okay, so we're putting a queen right here just to try it out, see if that works. So while such as, oh, I did that. Okay, set the location of the queen in column call to that square. If this was the final queen to be placed, oops, that's missing a D. So that's not the case, right? It's not the final queen to be placed. How would I know if it was the final queen to be placed? It would depend on what column I was in, right? So in our case, we're doing a 4x4 board. I would know that this is the final queen to be placed if I was in column 3, right? Because I'm working my way across the board. Once I get to column 3, if I place a queen in column 3 successfully, I'm done. That was the last queen to be placed. Okay, so you just have to check what column you're on. So in our case, we're in column 0, so it was not the final queen to be placed. Or, and now here's our recursive call. Place queens starting with row 0 in the next column over, which will be column 1, right? Okay, so I want to stop there for a second and kind of try to take a look at the bigger picture here. What's happening here is that this while loop, if everything goes smoothly and I keep placing queens successfully in each column, eventually it's going to get to this point where it was the final queen to be placed and I'm going to return true. Done, right? The only time I'm going to make it to the end of this while loop is if I got stuck, right? I got to column 3, there wasn't any place to put the column. Or let me rephrase that. I tried putting a queen in the next column. I tried every possible way of putting a queen in the next column. None of them worked. That pumps me out of the while loop and I return false. Meaning that didn't work out. You're going to have to try something different. Okay. Not expecting this to make total 100% sense just yet, but giving it a try. Okay, so let's go back to the details. We're doing our recursive call, right? We are calling place queens with row equal to 0 and column equal to 1. So I'm going to think of this as a separate instance of the place queens function. Row is going to be 0, column is going to be 1. Okay, and so now I'm back at the top of my place queens function. Beginning with row 0, find the next square in column 1 that is safe. All right, let's do that. We're in row 0. We're in column 1. Is row 0 safe in column 1?
No.
No, because it can be attacked, right? Is row 1 in column 1 safe?
No.
No, because it can be attacked this way. I guess if you don't know enough chess to know that, you might need to just do a little Wikipedia or something. So the next, row 2, this is row 2, right? Is row 2 safe?
Yep.
Yes. Okay, so we found the next square in column 1 that is safe. So we enter the while loop, and it says set the location of the queen in column 1 to that square. So I'm going to indicate that by putting an X. Okay. If this was the final queen to be placed, well, it wasn't. Or, guess what? Now we're going to do a recursive call to try to place the queen in column 2. Okay, so another instance of my place queens function now, with row is going to be 0, column is going to be column plus 1, which is 2. And now I'm back at the top of my place queens function again. All right, beginning with row 0, find the next square in column 2 that is safe. Okay, so is row 0 safe? No, because you're going to get attacked by here. Is row 1 safe? No, because it can be attacked by this guy. Is row 2 safe? No, because it can be attacked by this guy. I shouldn't say guy, huh? Is row 3 safe? No, because it can be attacked by this queen here. Okay, so we're on the first step. Find the next square in column call that is safe. Turns out there are none. No such square exists, right? So we get to the while loop. It says while such a square exists. Well, it doesn't. So we exit the while loop, come down here, return false. Okay, so that means this goes away, right? We're done with this instance of the place queens function. We got to the end of the function and we hit the return false. That goes away. And we're back here when we called place queens before from this instance of the place queens function, and it came back false. So we're not going to return true because this came back false. We're going to do the else part. Okay, so what that means is that we tried placing the queen in column 0, column 1, row 0. That didn't work because when we went to column 2, we couldn't find a spot. So what we're going to do is we're going to move that queen in column 1 to the next square in the column. Okay, so I'm going to delete it from here. I'm going to move it down here. I'm going to change the value of row to reflect that. So row is going to be 3. And now I finished the else part, and now I'm on this line here that says beginning with row 3, find the next square in column 1 that is safe. I'm reading from this information right here because this is the instance of the place queens function that I am currently executing. So beginning with row 3, find the next square in column call that is safe. Just to be, this is kind of a technical detail, but to be clear, that includes the current cell, right? So in this case, the next square in column 1 that is safe is row 3. This is safe, right? So back to the top of our while loop, because that was the last statement in our while loop. So we're back at the top of our while loop now. While such a square exists, it does. Set the location of the queen in column call to that square. That's a little redundant. It already is there, but that's just how the way the code works out. Okay. If this was the final queen to be placed, it's not the final queen to be placed because it's only column 1, or place queens 0, 2. Okay, so now another recursive call to the place queens function with row 0, column 2. So see what we're doing now. We tried row, I think it was 2, right? We tried row 2, column 1. We did our recursive call. It came back and said, nothing works. So now we're moving down and trying row 3 of column 1 and making the recursive call again. Okay, let's keep going. So now we're at the top of the place queens function again with row equal to 0, column equal to 2. Beginning with row 0, find the next square in column 2 that is safe. Row 0, not safe. Row 1, I believe that's safe, right? So we found out that row 1 is going to be safe. While such a square exists, set the location of the queen in column 2 to that square. So that just means I'm putting an X there. Okay. Now I'm back to this if statement. If this was the final queen to be placed, it's not, I'm only on column 2, or recursive call, place queens, row 0, column 3. Okay, so I'm back at the top of my place queens function. Beginning with row 0, find the next square in column 3 that is safe. Okay, is row 0 safe? No. Is row 1 safe? No. Is row 2 safe? No. Is row 3 safe? No. Okay, so we have while such a square exists, it doesn't exist. So we don't enter the while loop. We come down here and we return false, which means this goes away. We're back to this instance of the place queens function. We had just called place queens right here and it came back false. So that means we're not going to return true. We're going to do this stuff here. Move the queen in column 2 to the next square in that column. Move the queen in column 2 to the next square in that column. Set the row equal to that. So row is going to be 2. Now I'm done with the else part there. Now I'm at this statement. Beginning with row 2, find the next square in column 2 that is safe. Well, the row 2 is not safe. Row 3 is not safe. There isn't one. Okay, so we're back at the top of our while loop. It says while such a square exists, it does not exist. So we exit the while loop, we return false. That means this stuff goes away. And we're back here to where we had called place queens. It came back false. So we're going to go down to the else part, move the queen in column 1 to the next square in that column. Well, turns out that there is no next row in that column. So when we get to the beginning with row, find the next square in column call that is safe. There's not going to be one. So we're going to exit the while loop and we're going to return false again. So now this stuff goes away. And we're back to row 0, column 0, just having called the place queens function. Okay, so back at the very beginning, we tried to call place queens with column equal to 1, and we went through all of this stuff and we found out it's not going to work. There is no solution. So what we're going to have to do is go to the else part, move the queen in column 0 to the next square in that column. And set row equal to that value, which is 1. So now row is going to equal 1. Okay, so we're all the way back at the beginning now. I think this is going to start going a little faster, so bear with me for a couple more minutes. If this was the final queen to be placed, well, it wasn't, or recursive call, row equals 0, column equals 1. Okay, so now we're back at the top of our place queens function, beginning with row 0. I'm reading it from here, right? Beginning with row 0, find the next square in column 1 that is safe. So row 0, not safe. Row 1, not safe. By the way, remember when we talk about safe, we're only talking about the queens to the left, right? These, we're ignoring these for now. Row 2, not safe. Row 3, safe.
Well, Dave, I have a question. Do
Okay.
those from row 1 and 2 still exist there, or did you just leave them there?
Well,
for
they're still there just because there was no no reason to delete them. But we're just ignoring the fact that they're there. Does that make sense?
now? Okay.
Because this is the calling object. You could sort of think of it as like a global. But what really matters is that we know we're in column 1 and we're looking for a safe spot, and we find out that the safe spot is going to be in row 3. So we set the location of the queen in column 1 to that square. I just did that by putting the X there. If this was the final queen to be placed, it wasn't. Or place queens row 0, column 2. Okay, back to the top of the place queens function. Beginning with row 0, find the next square in column 2 that is safe. Well, it turns out that row 0 is safe, right? So such a square exists. So set the location of the queen in column 2 to that square. If this was the final queen to be placed, it wasn't. Or place queens row 0, column 3. New instance of the place queens function. Back to the top, beginning with row 0, find the next square in column 3 that is safe. Row 0, not safe. Row 1, not safe. Row 2, safe. Okay, so we're back to the top of the while loop. Such a square does exist. So we set the location of the queen in column 3 to that square. If this was the final queen to be placed, well, now that's true, right? That's the final queen to be placed. So what we do is we return true. So what that means is that this instance of the place queens function is done. And we're going back to this instance of the place queens function. We just called place queens from right here. The return value from that call turned out to be true. So that means that we execute the if part, which says return true. So now we're just unwinding the stack, right? The return true makes this go away. And we go back to this instance of the place queens function. We had just called place queens. The result came back true. So we execute the if part, which says to return true. Since we're returning, local data goes away. And we go back to where we had just called place queens. Turned out that the return value was true. So that makes the if condition true. So we're going to execute the return true, which makes this stuff go away. And at that point, we are back to whatever function called the place queens function to start with. And we have the queens placed on the board successfully. Okay. So I'm sure that sitting and listening to that for 10 minutes was probably fairly painful. And if I were you, I'd probably be thinking, I'm kind of lost. I'm going to just watch the video later, which is fine. But I think that's a pretty good exercise in understanding what's really going on when we backtrack using recursion. All right. Any questions about any of that? Okay. It'd be really great if some of you got a chance to get a little bit of a start on the program before Thursday, maybe come back with some questions. I don't really have too much more that I want to cover other than just maybe talking a little bit more about the details of the assignment. But all right. I will see you guys Thursday.
Thank you.
You're welcome.
Thank you, Dave.
All right. See you.